Hey everyone, and welcome back to Summarize Science. Have you ever wondered what happens when you blast materials with some of the most powerful lasers in the world? Physicists have been doing this for decades, creating incredibly short bursts of light to study the universe at the atomic scale. For a long time, they treated these super-intense lasers as simple, powerful waves of classical light. But this paper, Quantum Optics and Quantum Electrodynamics of Strong Field Processes, argues that this old view is holding science back. The authors propose that it's time to bring back a fully quantum description of light to understand these extreme interactions. Why? Because it turns out these powerful laser-matter interactions are not just good for seeing things, they're good for creating things. We're talking about generating bizarre and useful quantum states of light. Imagine creating Schrodinger's cat states, where light is essentially in two different states at the exact same time. Or generating light and matter that are entangled, meaning their fates are linked no matter how far apart they are. These aren't just lab curiosities, they are the fundamental building blocks for future quantum technologies. Of course, this opens up a whole new set of challenges for researchers to solve. First, they need to figure out how to create these quantum states on a massive scale, not just in tiny amounts. They also want to generate deep entanglement between the light and the materials themselves. Then, they have to develop new tools to measure these states and even simulate these complex processes using other quantum systems. Luckily, scientists aren't starting from scratch. New theories and computer models are making it possible to predict what will happen. They're also using brand new materials like ultra-thin 2D sheets and exotic, topological insulators as their testbeds. And they're developing special light sources that are already quantum in nature to begin with. So, let's recap the big picture here. Researchers are merging two huge fields, the physics of ultra-powerful lasers and the strange world of quantum optics. They've discovered that strong field processes can be used not just to observe matter, but to engineer these special non-classical states. This means treating both the super-intense light and the matter it hits as fully quantum entities is the key to the next breakthrough. What could this mean for the future? This work lays the foundation for a new generation of technologies. We could see the development of new quantum light sources, platforms for quantum simulation, and maybe even ultra-fast quantum processors. It's a roadmap to harnessing the most extreme light-matter interactions to build the next generation of quantum tools. That's all for this summary. Thanks for watching Summarize Science.